Hi everyone, this is Dr. T. Janishba from the Department of Chemistry, Rohini College of Engineering and Technology, and this lecture is about batteries. So, what is a battery? A battery is a device consisting of two or more galvanic cells connected in series or parallel or both. And what are the principal components of a battery? An anode where oxidation occurs, a cathode where reduction occurs, an electrolyte which is ionically conducting, and a separator to separate anode and cathode compartments. And the diagram shows an anode, cathode, electrolyte, and a separator, as you can see. And next, we can how to classify batteries. Batteries are classified into four types: the primary batteries, secondary batteries, reserve batteries, and flow battery or the fuel cell. So primary batteries, here the cell reactions are not reversed and they also cannot be recharged. Example, the zinc manganese dioxide, which is the dry cell. Secondary batteries, the cell reaction can be completely reversed after discharging and they are also rechargeable. Example, lead acid battery, nickel battery. And the reserve batteries, in these batteries one of the active components, that is electrolyte, is separated from the rest of the components. It is assembled just before the use. Example, magnesium water activated battery. And next one is the flow battery or the fuel cell. The fuel cells are galvanic cells in which the chemical energy of fuel is directly converted into electrical energy. The reactants are continuously passing through the cell, hence it is known as the flow battery. So let us see about the dry cell or the Lagrange cell. The Lagrange cell is called the dry cell because the absence of any liquid phase. It is a primary battery. The anode is zinc, the cathode is carbon rod, it is the graphite, and the electrolyte is ammonium chloride mixed with zinc chloride, a manganese dioxide, starch and water, and the EMF obtained is 1.5 volt. So you can see the diagram. It consists of a zinc anode, a zinc cylinder which is acting as an anode, and you can see a carbon rod which is immersed into it, and then we have the electrolyte which is ammonium chloride, zinc chloride, manganese dioxide, starch and water, which is in the form of a paste. Now what are the reactions? The cell reactions at two electrodes are given below. At the anode, zinc oxidizes to zinc 2 plus, and at the cathode, ammonium ions and manganese dioxide are converted into manganese oxide hydroxide and ammonia gas is released. And during this reaction, 1.5 volt energy is released. And the second reactions that are taking place is we use when you can see the evolution of ammonia gas. Hence, this ammonia gas has to be absorbed, and zinc chloride is placed in order to absorb the zinc. In order to absorb the ammonia, and it is converting into a complex. The second reaction does not contribute to the EMF of a cell. The voltage of Lagrange cell is about 1.5 volt. And what are the advantages? These cells have a voltage ranging from 1.25 to 1.5 volt. The cost is low. The compact size of the battery makes it suitable for powering or small electronic devices. The electrolyte used in dry cell is not so harmful to the environment. It is a portable source of electrical energy. Even in hot weathers, it performs better due to better other than the other batteries. And the disadvantages: these cells do not have long life, and these cells cannot be recharged. Lifetime is not definite. The voltage decreases with the continuous usage due to the accumulation of products at the electrode and uses. They are used in flashlights, radios, tape recorders, transistors, etc. And next is the lead storage battery, which is otherwise known as a lead acid battery. This is a secondary battery which can operate both as voltaic as well as electrolytic cell. When it is acting as a voltaic cell, it supplies electrical energy and becomes run down. While recharging, the cell acts as electrolytic cell, and you can see the diagram also parallelly when I say the components. So it is secondary battery. The anode is lead and the cathode is lead dioxide plates, and electrolyte is aqueous sulfuric acid. The anode and cathode are immersed in the electrolytic solution, and the cell notation is as given below. And the working: when it is discharging at the anode, the lead undergoes oxidation and forms lead sulfate. It reacts with the sulfuric acid to form lead sulfate. At the cathode, the lead dioxide is reduced to P2 plus ions, which further combines with sulfate ions to form again insoluble lead sulfate. So hence at the anode and cathode, lead sulfate is accumulated. So the overall reaction shows the accumulation of lead sulfate. And also we can say that the density of or concentration of sulfuric acid decreases, hence the density of sulfuric acid falls below 1.2 gram per ml. So the battery needs recharging. So when we go for recharging, the current should be passed in the opposite direction. The electrode reactions get reversed. As a result, the lead sulfate dissociates to again lead and gets deposited at the anode, and lead dioxide gets deposited at the cathode. And also the density of sulfuric acid increases. So then the reaction is shown as below. And the advantages, it produces very high current. It is highly reliable and robust. It acts effectively at low temperatures. The self-discharging rate is low when compared to other batteries. It is simple and inexpensive to manufacture, low cost of maintenance. It maintains large power in comparison to its weight. It can be recycled. Disadvantages: the mechanical strain reduces battery capacity. Recycling of this battery causes environmental hazards. It cannot be stored in a discharged condition. Danger of overheating during fast charging. Uses: it is used to supply current for electric vehicles, automobiles like cars, gas ignition, and telephone exchanges, railway trains, mines, hospitals, etc. It is a standby backup power for electrical installations, submarines, etc. Hope you all understood about the dry cell as well as the lead acid battery. Thank you for watching. Thank you once again.